We're right in the middle of this huge artificial intelligence revolution. We're building these incredible machines to make decisions that are smarter, faster, and most importantly, objective. But here's the thing. What happens when these supposedly impartial machines end up learning our oldest and most destructive prejudices?
I mean, the whole promise was simple, right? The idea was to create systems that just run on pure data. Systems that could finally get past all the flawed, emotional, and, let's be honest, often biased judgment that we humans have. The goal? To make things way more fair for everyone. And that is the huge question we're going to dig into. Because there's all this mounting evidence that suggests that instead of getting rid of bias, we might just be, hiding it, automating it, and maybe even worse, amplifying it on a massive, massive scale.
Okay, so to really get what's at stake here, first we have to look at just how deeply these algorithms are already tangled up in our lives. I mean, they're making absolutely life-altering decisions, a lot of the time with zero human oversight. I mean, just think about it for a second. Algorithms are deciding the Google search results you see, the news that pops up in your feed, even the ads for high-paying jobs that you get shown. But it goes so much deeper. They're being used in these incredibly high-stakes situations, deciding who gets a mortgage, who even gets a job interview, where police should patrol, and even helping judges figure out criminal sentences.
And look, this isn't just about one or two faulty programs. It's not that simple. Across so many different applications, we're starting to see this really disturbing pattern of bias pop up again and again. These aren't just little glitches in the system. They're basically a mirror, reflecting the bias data we're feeding them in the first place.
Okay, let's take facial recognition, for example. An MIT study found that some of the biggest systems out there could identify a person's gender correctly 99% of the time. But, and this is a huge but, only for white men. When it came to dark-skinned women, the accuracy just plummeted, all the way down to 35%. And the reason? It's actually pretty simple. The data they used to train the AI was just jam-packed with images of white men.
Or how about this one? A study found that if you go and search for CEO on Google Images, only about 11% of the results you see are women. That's despite the fact that women hold 27% of those jobs. What's likely happening is that the algorithm just learned from what people click on. If more people click on pictures of men for that search, the algorithm learns, okay, I guess I should show more men, and it ends up reinforcing that stereotype in this crazy, vicious cycle.
And sometimes, the consequences are immediate and incredibly severe. Get this. There was a case where a Palestinian worker posted a picture of himself online. The caption in Arabic just said, "Good morning." But Facebook's automatic translation tool messed it up big time. It mistranslated it to attack them in Hebrew, and because of that, he was wrongfully arrested. A single, tiny data error had a huge, life-changing human cost.
All right, so now let's really zoom in on one of the most controversial, highest-stakes places where this tech is being used: law enforcement.
So, welcome to the world of what's called predictive policing. The idea, on the surface, sounds pretty cool. You use historical data to try and forecast crime before it even happens, telling police where they should focus their energy. It sounds super efficient, almost futuristic, right? But the reality is way, way more complicated.
So basically, these tools come in two main flavors. First, you've got the location-based ones. They act kind of like a crime weather forecast, predicting these hotspots where police should go patrol. And then you have person-based tools. These are the ones used in courts to create a risk score that tries to predict how likely a specific person is to commit another crime.
And, this isn't just some abstract technical debate. As activist Yeshimabe Milner explains, for her it is deeply personal. She talks about seeing her own classmates get arrested at a peaceful protest. And now that arrest data, it lives forever inside a system, and it can be weaponized against their community by these very same algorithms.
So how does this actually happen? Well, the core of the problem is something researchers call the feedback loop of bias.
Okay, this is probably the most important part to understand. These algorithms are not being trained on crime data. That doesn't really exist in a clean, objective way. Instead, they're trained on arrest data. And what is arrest data? It's just a record of where police have made arrests in the past. It reflects policing patterns and priorities, not necessarily a true, perfect map of where all crime is actually happening.
And this is where that feedback loop really kicks in. It works like this. You start with historical arrest data, which might already be biased. The AI learns from this skewed data and says, hey, more crime is going to happen in these same communities. So what happens next? Police get sent to these AI-generated hotspots. And because there are more police there, they make more arrests. And guess what? That just feeds right back into the system, proving to the algorithm that it was right all along.
It's like a self-fulfilling prophecy, a digital trap.
Just as researcher Katie Weddington says, it's just been a self-reinforcing loop, over and over again. It takes all the bad data from the past and uses shiny new technology to make it even worse, basically locking in those historical biases for the future.
And what makes this whole problem even harder to untangle is that a lot of the time, we have absolutely no idea how these systems are making their decisions. It's a total black box.
See, many of these predictive policing tools are built by private companies. They're sold to police departments as proprietary software. That means the exact code, the specific data it was trained on, the logic it uses, it's all locked away as a trade secret. And that means nobody, not the public, not researchers, can really audit them or check them for bias.
So you end up with this huge gap between the promise and the reality. The promise is all about being objective, efficient, and fair. But the reality? It's proprietary software. No public audits, totally opaque decision-making. Police departments can literally buy these powerful tools with about as much oversight as they'd have buying a new snowplow, with no real way of knowing if they're actually fair or if they even work. Which, of course, brings us to the final, and maybe the toughest question of all. If we know these systems are biased, can we actually fix them? And what does fairness even mean when you're talking about an algorithm? This is really the heart of the debate right now. Some researchers are proposing what you could call a kind of algorithmic affirmative action. The idea is that to counteract all that biased historical data, maybe you have to program the algorithm with different risk thresholds for different groups. So, for example, it might treat 3 arrests for a black person as being the same risk level as 2 arrests for a white person. Now, as you can probably imagine, this idea is extremely controversial. It means you're intentionally programming a machine to treat people differently based on their race in order to get a more equitable outcome. And that's an idea that makes a lot of people, for good reason, really uncomfortable. It kind of challenges our fundamental belief that fairness means treating every single person the exact same way. And maybe that's the real takeaway here. Alice Yang from the Partnership on AI puts it perfectly. This isn't really a technical problem that has some neat, clean, mathematical solution. The code is just a mirror, and it's reflecting a much deeper, much more human question back at us. What does a truly fair criminal justice system and a truly fair society actually look like? And that's a question that technology just can't answer for us.